Welcome to TSAT. Today I am going to discuss about nanotechnology. In this context of nanotechnology, one of the most emerging technologies recently. So why this is considered as one of the most emerging technologies recently? Because it has got the capacity where we can apply this technology in different areas. This can be applied in textiles, automobiles, medical aspects, and in engineering aspects in different areas. This technology has got the capacity where we can apply in different areas for advantage. So in this context, what is nanotechnology? Nanotechnology is a technology where we are able to control material at nanoscale. Mathematically, nano implies that it is the size at the level of 10 to the power of minus 9. But in this context, trying to control material at microscales. So why we need to control material at microscales? What are the different kinds of advantages we have got as far as nanotechnology is considered when we are able to control material at microscales? When we are able to control material at microscales, we are experiencing nano impact. So what do you mean by nano impact? Nano impact is a condition where when we are able to divide the particles at microscopic level, at the level of molecules and controlling material, one aspect is the rate of reaction is being increased. Why the rate of reaction is being increased is the surface area provided by the material to react is increasing when the particulate size of the material is being divided from macro scale to microscale. That is one of the reasons for nano impact. So here, apart from the other factors, the other reason for the nano impact is quantum effect. So quantum effect is one of the main reasons for nanotechnology. So what do you mean by quantum effect? So these are the aspects which I am going to discuss with you to explain you what nanotechnology is. So first, let us understand what nanotechnology is by discussing different topics related to nanotechnology. Richard Feynman is the scientist who has first where he is considered as the father of nanotechnology. So after the discovery or innovation of these microscopes, scanning tunnel microscope and atomic force microscope, we are able to have this nanotechnology because these are the microscopes which are able to view the microscopic level of matter. That is the reason why nanotechnology has been innovated after the innovation of these microscopes. So Richard Feynman told that there is plenty of room at the bottom. So what do you mean by this? There is a plenty of room at the bottom means when the matter is subdivided into microscopic level at the level of atoms and molecules, the probability of converting and controlling this matter at microscopic level helps in manipulating matter as you desire. In terms of this, matter is considered in terms of conductivity, strength, durability, reactivity, magnetic impact. These characters of matter, when relatively compared from microscopic level to macroscopic level, the characters are not the same. At macroscopic level, a material is behaving differently. At microscopic level, a material is behaving differently. The difference in the behavior of material and relatively compared between macro scale and micro scale is because of nano impact. Because nano impact is a condition where when you are subdividing the particles at micro level, the rate of reaction is increasing because the total surface area provided by the same material is more, so the rate of reaction is more. So here in this context, before showing what it is, nanotechnology is the study of phenomena and manipulation of materials at atomic, molecular and macromolecular scale, where properties of matter differ significantly from those at macro scale to micro scale. So we have observed that the same material is behaving completely differently in terms of its physical and chemical characteristic features because of nano impact. So this is what nanotechnology is. Nanoscience and nanotechnology are the study and applications of extremely small things and can be used across the other sciences fields such as chemistry, biology, physics, material science and engineering. So, here this context in controlling different kinds of chemicals in terms of chemistry which can be used in different areas like fuels, chemicals, pharmaceuticals, etc. Biology in terms of living beings, able to view the microscopic level of the cells and the way the cells are functioning, which can help in controlling the physiology for better treatment in terms of biology. Physics, you are able to find materials which are having high durability, superconducting materials which helps in saving a lot of power and energy. And material science, you are able to make materials so tough, or you can make materials as you desire. At a point a material must be so rigid, at a point a material must be flexible according to your requirement. With the help of nanotechnology, you can make materials of a physical or a chemical characters of your requirement, which varies from condition to condition, because you can control materials at nanoscales because of nano impact. So, these are all the different areas where nanotechnology is being applied. Nanotechnology is the design, characterization, production and application of structures, devices and systems by controlling, shaping and size at nanometer scale. So, you are controlling materials at nanoscales, that is where you are getting the advantage of nanotechnology. The concept of nanotechnology first explained by Richard Feynman. He is the one who has first explained this, which is one of the important aspects which can be asked even in objective bits. And when you are writing about nanotechnology, you must mention this word where who has first hypothecated this technology to prove it. So, these are the different areas where nanotechnology is being used in information technology, in semiconductors, nano MEMS, other applications in terms of hybrid materials. Hybrid materials are materials when you are mixing some kind of organic and inorganic material, because of which the strength increases to the material and the weight decreases, which are being used better in construction materials. For example, adding carbon nanotubes to concrete helps in increasing the strength of the concrete, and the weight of the concrete decreases, so that the durability of building and the lifespan of the building increases because of the application of nanotechnology. So, these are the different areas where nanotechnology is being applied. So, to make you understand the scale at which the nano particles are, when you relatively compare the size of the human being and the size of the hair follicle you have got, and from the size of the hair follicle to the size of the 𝗹𝗶𝗍 in our blood, from the size of the 𝗹𝗶𝗍 we are comparing the DNA molecule in the nucleus. So, this is a relative comparison to understand what nanoscale is, which is at the level of molecule inside the nucleus of a cell. This nano impact is because of two factors. One is increased relative surface area. The second is dominance of quantum effect. These are the two factors which are responsible for nano impact. So, what do you mean by this? Increasing in the relative surface area and dominance of quantum effect. These are the two factors which are responsible for nanotechnology. So, what are these? Let us examine. So, you see here, for example, take a cube. Where the surface area of this cube is 6 centimeters square. When you divide the same cube into 8 parts, the total surface area of the 8 parts of the cube is 12 centimeters square. When this 8 is being divided into these many number of cubes, sliced into these many number of cubes, the surface area being provided by this total number of cubes is 24 centimeters square. See this, the amount of matter is the same. When you are gradually reducing the size of the particle, what is happening is the surface area offered by the matter is increasing, so that the rate of reaction offered to other material to react is gradually increasing when the particulate size is decreasing, leading to increasing in the rate of reaction. is one of the reasons for nano impact, changing in the nature of the material when you relatively compared between macro and micro scale. The second factor for nano impact is quantum effect. So, quantum effect is the involvement of fundamental particles in the reaction is been described as quantum effect. In this context, the modern physics, according to modern physics, the matter is made up of fundamental particles. Fundamental particles are particles of matter which are indivisible. Apart from the classical physics, what it says is matter is made up of atoms. Atoms contains protons, electrons and neutrons. So, with the discovery and innovation, we are able to know that matter is not just made up of protons, electrons and neutrons. Matter is made up of many number of such fundamental particles as been projected to you, like leptons, bosons and fermions. So, quarks, leptons and bosons and fermions, all these are subatomic particles which are been described as fundamental particles. These fundamental particles are particles which are considered as particles which cannot be divided. A particle which is indivisible is considered as a fundamental particle. So, these fundamental particles are being classified into these variants of quarks, leptons and bosons. So, these quarks, leptons and bosons are being classified where they are just particles of matter. They are being classified into these variants based upon their size, spin, charge, force they have got. So, based upon the similarities, they have been classified into these three different variant types of fundamental particles out of many number of fundamental particles being discovered. So, these fundamental particles take part in the reaction when matter is being controlled at micro scale, at nanoscale, and because of this reason, the nature of the element in terms of specific characters being discussed with you in terms of durability, strength, conductivity, magnetic impact, they are drastically different when relatively compared at macro and micro scale. So, because of this reason, the rate of reaction, the nature of the material are being impacted, and you are able to acquire a desired character to a material in terms of conductivity, magnetic impact, density, strength, durability by controlling the proportionate amount of fundamental particles, and you are acquiring a character of your desire and requirement varying from conditions to conditions to have the advantage. This is the main advantage with the nanotechnology. So, because you are able to control material at nanoscales, you can make structures at micro level, or you can decrease the size of the structures, electronic systems. At the same time, you can increase the strength, and you can apply this technology in different areas. For example, the one which is being projected is a camera, a laser camera, which can be swallowed inside, and it can take the video of your intestines clearly for a better diagnosis rather than going for endoscopy or laparoscopy, which creates a lot of problem for the patients when the tubes are being introduced into the mouth and to the internal organs. Patients feel so uneasy. But with this laser camera, with nanotechnology, swallowing this will help you to take the video with a laser camera with a more clear-cut imaging, helps in better diagnosis. And this can take not only the video of the stomach and the large intestine, this can take a clear-cut video of even the small intestines and duodenum also, which is not possible with the traditional techniques. Is an application of nanotechnology. Other application of nanotechnology is microscopic drones. So, you are able to condense the size of the particle so small that the drones can fly which cannot be identified. You can make them fly in the enemy territory to acquire the essential information for your advantage. The other application of nanotechnology is macroscopic gold is chemically inert whereas at nanoscale gold becomes extremely reactive, catalytic and even melt at lower temperatures, and increase in the surface area will result in an increase in a chemical reactivity. So, what do you mean by this here? Gold is doesn't react much at macro scales, but when you are able to control at microscopic level, at nanoscale, the gold melts at lower level, which can act as a better catalyst, which can also be used in photovoltaics for better power generation. So, gold in general, which has got the higher melting point where it has got around 1100 degrees Celsius or so, which will be melting at around 300 degrees Celsius, changing its melting point, changing its nature, so that which can be used for an advantage in the case of macroscopic gold, and when it is being turned into microscopic level. At the size of matter, as the size of matter is reduced to nanoscale, quantum mechanical effect can play a role and lead to new physics and chemistry. This significantly changes material magnetic and electrical properties. So, what is happening when the size of the material is being decreased, the way the material behaving is being changed, which is known as quantum impact, because the fundamental particles get into action to change the reaction or to change the nature of the element, which we are using this change for our advantage. Nanotechnology is classified into two. One is top-down and the second one is bottom-up approach. In top-down, technology involves the fabrication of nanoscale structures to convert into microstructures. So, you are converting structure as microscopic as possible. In certain conditions, when the structure is microscopic, you have got a lot of advantage. The classic example which I have shown to you is a laser pill camera, which can be swallowed, which will be able to make a video with the first hand information. The doctor will be able to diagnose the reason why an individual is suffering with certain problems or ulcers in the stomach. Bottom-up approach refers to the creation of organic and inorganic structures to a megastructure level. So, in the difference between top-down and bottom-up approach is, in the case of top-down approach, you are dividing the material and controlling the material at nanoscales and constructing microscopic structures as you like. In the case of bottom-up approach, you are constructing megastructures by controlling material at nanoscales. The quality of the material megastructure constructed will be of your desired quality, which will be acquiring your desired characteristic features. So, nanotechnology has been applied in these two ways. One is top-down approach, the other one is bottom-up approach. Top-down approach is being proved and it is being experimented and it is being used in many areas, but in the case of bottom-up approach, this bottom-up approach is still under hypothetical condition, means which need to be proved at. So, the challenge for the bottom-up approach is to create a mega structure with quality. So, that is one aspect where a quality structure need to be made of your desired character, quality and material. Constructing a larger structure of your desired character can be made with the help of bottom-up approach. Another classic example of application of nanotechnology is carbon nanotubes, where first observed by 𝗬𝗎𝗎 in 1991. CNT means carbon nanotubes are extended tubes of graphite sheets. So, carbon nanotubes are being made with graphite. The other application of nanotechnology is allotropic forms of carbon C60, one which is known as Buckminster Fuller. The advantage with Buckminster Fuller is, this is a material which can be used for targeted drug delivery and lubrication of very large machinery. So, with the help of targeted drug delivery system, you can use the medicines to reach the required organ of your body exactly, so that the amount of mg of medicine you need to consume can be minimized, so that the side effects can be reduced. So, Buckminster Fuller is a allotropic form of carbon which is used in targeted drug delivery, means you can send the medicine only to the affected organ of your body. So, the problem with Buckminster Fuller is this is a material which is not available on the surface of the earth, which is observed in meteorites. So, with the help of nanotechnology, you can manufacture Buckminster Fuller, an allotropic form of carbon, the largest molecule of carbon, for these applications and purposes to solve our problems. So, nanotechnology is creating a molecule which is not available to us to have an advantage. So, what are the different applications of nanotechnology? Nanomaterials has multi-functional applications because of desired mechanical properties. So, mechanical properties, if a structure is very strong, is a mechanical property. The flexibility, the physical strength, rigidity, all these are considered as mechanical properties. So, with the help of this technology, you can convert a material as you like. If you want to make it rigid, or if you wanted to make it flexible as you require, the materials can be transformed with nanotechnology. Optical properties means a material which is acting or allowing the light to flow and controlling the light to flow in a different direction. You may want the light to converge at a place or diverge at a place, or you want a material to be opaque, you want a material to be transparent, you want a material to be translucent with the desired characters in terms of strength and brittleness. With the nanotechnology, even not only the durability, the opacity of a material means the capacity of a substance allowing the light to travel through can be maintained. So, which has been applied in optics preparation, the nanotechnology can also be applied. So, electrical conductivity, you want at a point of time a material to be insulator, at a point of time you want a material to be a superconductor and a conductor. So, you can change the nature of conduction of electricity with the help of nanotechnology. You can convert a material into an insulator or a superconductor as you desire. The magnetic properties and other properties can be altered. Clay containing naturally occurring nanoparticles has long been important as construction material. So, clay with nanotechnology, which can be used in the purpose of construction with the help of nanotechnology. So, the other application is arrangement of a range of enhanced textiles such as breathable, waterproof and stain resistance fabrics. So, what is happening here is enhanced textiles. So, what happens is breathable means a clothing which you are wearing is comfortable, which helps in the passage of air comfortably, so that you feel comfortable when the air is passing through the clothes comfortably, which are known as a breathable. Waterproof, at a time when you are moving in rain, you must have better waterproof materials. Stain resistance materials. So, if there is any tea or coffee stains on your clothes, it looks odd. So, but these are certain fabrics where they are not being stained unnecessarily. So, stain free clothes can also be made with the help of nanotechnology. Nanotechnology is also used for precise delivery of drugs to specific organs. With Buckminster Fuller, can manufacture cables which can connect earth to celestial bodies capable of carrying vehicles and conduct energy. So, in future we will be connecting a cable elevator to the moon. You need not go with a rocket always. You can develop structures, cables connecting to celestial bodies like moon, so that traveling to the moon becomes very easy through an elevator, and transporting the essential resource from the moon, which have got a very good valuable minerals there, can be transported to earth easily with the nano cables. So, these are nano robots. So, these are nano robots means at microscopic level you can make robots which are traveling in your bloodstream, eliminating certain bacteria, viruses, waste materials, etc. can be removed. See this is a robot moving in your blood vessel with a laser camera, killing the microbes with a laser camera, so that it can control the infection. So, these are the range of applications where nanotechnology has been applied. In textiles, better breathable textiles, textiles which are wrinkle free, textiles which are antibacterial. So, these are the different range of applications. For example, in the biomedical applications, a drug delivery system with the help of Buckminster Fuller, you can synthesize materials of your desire which are accepted by your immunity. So, for example, you can mimic a material so that this material which is artificially synthesized will be accepted by your immune system, so that you can use that material as an organ in your body, like knee replacement surgery, etc. You can make materials which are biocompatible, which are known as bioncs, which are not been rejected by your immune system. Is an application. Healthcare, food and agriculture. With nanotechnology, you can make food materials where you can preserve for a longer duration with the help of nanotechnology. Industrial applications, electronics, in terms of making materials which has got superconductive materials, where the size of the materials can be reduced with the help of nanotechnology. So, these are the different areas where nanotechnology is being applied. In the case of renewable sources of energy, nanotechnology is being applied. So, for example, you will be able to make fuels with nanotechnology so microscopic, where the same amount of fuel can be made to release more amount of energy, because you make the fuel to divide at nanoscales and you burn the fuel, and the energy released is so huge that with the same amount of fuel you can generate more amount of energy which can be applied in different areas. So, this is how nanotechnology has got a great range of applications to have an advantage, from industrials, textiles, medical applications, automobiles, healthcare, environmental factors, and these are all the different areas where nanotechnology is being applied in environmental clearance, etc. So, friends, we shall meet in the next episode to discuss the other topics in science and technology.